Unanimity sounds quite nice, if you can get it. Even the majority vote, to some, means consensus. This is Data Skeptic Consensus, the second episode in our series about how multi-agent systems achieve collective decision-making. Today I'm speaking with Stephen Heilman about the mechanisms of voting. The Electoral College is a somewhat complicated example of a voting mechanism. Today we're exploring some of the mathematical tools to describe the different approaches to voting. There's some surprisingly counterintuitive results to unpack, and a lot to decide when deciding how to decide.
I'm Stephen Heilman. I'm an assistant professor, RTPC of mathematics at USC, the University of Southern California.
Excellent. And tell me a little bit about your general interest within mathematics before we get into the particular paper I wanted to talk to you about.
A few different topics. Generally speaking, probability generally construed, its relation to computer science, in particular theoretical computer science.
Would we wind up somewhere near, polynomial time pseudo-random number generators?
I don't know about pseudo-random number generators, but yeah, for sure. Polynomial time things. More specifically, say I have a problem that can't be solved in polynomial time, and then you want to approximate its solution, and you want to say, how well can I approximate it? Can I prove that this is the best you can do? Things like that, under the general category of hardness of approximation, I suppose.
Well, I know in a lot of those cases, you have one benefit, maybe many, but a benefit in a lot of problems like that is you can tell if a solution is valid, or you have some function you're trying to optimize for. I don't know if the same is true in voting. Is there a global way that we'd all agree that the outcomes are good or the process is good? Maybe that's a good way to get into your topic, designing stable elections.
Yeah, exactly. I mean, there's a lot of, I think I link a Wikipedia page somewhere that it's a table and it has a list of desirable properties of voting methods. And there's at least maybe 10 or 20 such properties. And it's impossible to have all the desirable properties. No matter which voting method you have, there's always going to be some that it has and some that it doesn't. But the one property that myself and many other people have focused is, how can the voting method be, say, protected from corruption? And that could be mostly what people in this community have worked on is looking at random vote corruption. So everybody casts their vote, and then say with some small probability, they will randomly change some votes. And then the question is, which voting method best preserves the election's outcome? So that's the quantity that you want to, say, maximize. You want to maximize the probability that the voting method preserves the outcome when you compare the original outcome to the outcome after the votes have been corrupted. That's one quantity you can try to maximize.
Very interesting. I definitely want to come back and talk more about corruption, but you've got me intrigued with those properties. And I know there's many of them. Maybe I don't want to put your memory to test, but could you talk about one or two and maybe discuss, if there's any controversy around them or why they're important or that sort of thing?
Yeah, so there's a bunch. One desirable property of a voting method is that it doesn't succumb to the spoiler effect, as we know the Electoral College does. So how can we think about the spoiler effect? So maybe let's change the names to some ancient names so we don't have to deal with too political of discussion at the moment. But let's say we ran an election, 200 years ago, and there's George Washington running, and there's also a clone of George Washington running, say, as different candidates, and there's some third candidate, I don't know who it is. So spoiler effect means the fact that two of these clones of George Washington are running, well, some people who originally, if there was just one George Washington, they would just vote for that first one. But since there's two of them, you'd imagine, the original George Washington supporters, some of them might vote for first George Washington and some might vote for evil George Washington or whatever you call the second one. So the fact that the original supporters of the person get split between, say, two separate candidates, we know in Electoral College that means that it decreases the chance of either one of them winning. And for example, I think last election cycle, Bloomberg said, I'm not going to run as an independent because of this spoiler effect. You can steal votes away from someone in a sense, and it can ruin the chance of, say, some candidate that maybe you kind of support or something. So that's a desirable property of a voting method that some of them have and some of them don't. That it doesn't have the spoiler effect. That's what you want.
Are there mechanisms then that can eliminate things like that? How do we build something like that into a voting framework?
Yes, one voting method that avoids this, it's become popular to certain people. It's not a perfect voting method, but it's called instant runoff voting. So this is a little different than what we're used to thinking about. Your vote is no longer just your favorite candidate. It's like a ranked list of candidates. Like, for example, I don't know, once again, going back 200 years or something, maybe your first choice, your most preferred candidate is George Washington. Maybe your second most preferred candidate is, I don't know, Alexander Hamilton. Your third most preferred candidate, I don't know, Harriet Tubman or something. I don't know. Every single person makes this list of their preferred candidates, and they all get submitted into whatever, the election method, which is some way of taking all those votes and just saying, okay, here's the winner. And so I think I mentioned already, one popular ranked choice voting method is called instant runoff voting. I believe it's used in Australia. I think it might even be used this coming election cycle in Maine. I'm not entirely sure. But anyway, so the important thing is this voting method does not have the spoiler effect.
Very interesting. Then, boy, I don't want either of us to get into a position of taking a political stance here, but would the Aussies tell us that they have better leaders as a result of this?
I don't know. I think they would say that their voting method is better. I don't know if they would say that the leaders are better.
Well, one thing that occurs to me as I read through your paper and learned about so many different types of voting mechanisms is that, or actually I was reminded of, like board games. Think of something like chess, and imagine if we instated a new rule where pawns could now move 3 spaces or something like that. I mean, it would still be a game, and I'm sure there would still be a grand master and all that, but it would probably radically change the way people play with just one little rule. Do the same things? Are we at risk of changing simple rules in voting and having massive desirable or undesirable changes?
Yeah, for sure. So if I could bring up that same example of this instant runoff voting. So, there's some properties that you'd like it to have that it doesn't have. So it has this rather undesirable effect that it's not monotone. So quick way of saying this is, say, ranking your candidate higher might actually hurt their chances of being elected, which is it's a little bit odd. There are these weird situations you can get in with instant runoff voting where that's not necessarily true. So yeah, as you said, that's, changing things can sometimes make things worse in some ways. And that's part of this balancing act of picking a good voting method. Is that some things are better, some things are worse? Who can really say what's the best? That's starting to get into opinion territory.
For sure, at the end of the day, something does come down to opinion. I think a lot of work on voting kind of tells us that, but we can formalize those opinions in like, you value X and I value Y types of things, I think anyway. Would you agree that at least there's a maturity in the conversation at that level, or are we still talking about the mechanisms?
That's a tough question. Yeah, it does seem to come down to opinion. So I wrote this general interest article at the Conversation and got picked up by like salon.com or something. Yeah, I got some comments on it that said, so the crux of the article was saying, if we look at this property of how can this election method be manipulated, like how easy is it to manipulate some election method, say Electoral College versus just a majority vote, something like that. If you just look at this property, then Electoral College it's just worse than majority voting. That once again specialize into just voting between 2 candidates. Some of the comments I got was that I'm ignoring certain, this or that social political issue, blah, blah, blah. For example, one of the main comments people say is, you're ignoring what the framers of the Constitution intended, which is the small and large states are supposed to be balanced out by the Electoral College. That's the whole point of it. That's one example of, a property that some people say that's an original part of the Constitution. It's something that it's supposed to be that way. And the fact that you're not focusing on that issue means you're wrong, something like that. So yeah, I would say that fact alone and others means, yeah, it does get into opinion. What's the best property of a voting method? It's really opinion territory, in my opinion.
When I think about voting, and I'm a citizen of the United States, if that's not obvious, so you could get the context of when I'm voting and how, I have always felt like I should just vote for the candidate I think is the best for the job. If we went to ranked choice, I might start thinking a bit strategically, like, well, I want to put someone in second to block and do all this kind of stuff, and suddenly there's a computational burden on me almost. Is that something to be considered?
Yeah, absolutely. And so, yeah, there's a fairly big literature on exactly what you just brought up, which is they sort of look at computational aspects of different voting methods. And I don't know much about about that, but I think it's interesting. But yeah, get back to your original point, ranked choice voting, there can be some non-obvious strategies, which, as you're saying, it can make thinking about voting harder. And therefore, you could say, that's not a good voting method. If I have to think about weird strategies of voting, that's totally counterintuitive. And people also say that about the voting method itself, where you have to, making a list of ranked candidates, that the argument goes, people are going to get confused. It's such a change. They're going to get confused. That's no good.
Well, maybe I have too much faith in people, but I'd like to think we could get past the confusion that not be the barrier. I don't know.
One would hope, but yeah, I don't know.
I guess with that in mind, as we kind of touched on, it comes down to opinion, but do you think there should be some sort of movement to explore alternative voting mechanisms? Might the public at large be better serviced if we experimented a little bit with some of these alternative approaches?
So getting into my opinion, I think it's worthwhile to think about these other voting methods. I wouldn't necessarily advocate for some upheaval of these methods, but yeah, sure. Having...
Yeah, I didn't mean you should commit treason. I just...
Thank you for acknowledging that. Like in Maine, where they're experimenting with this new voting method to see how it goes, I think that's a good thing. It's a nice thing to, in my opinion, it's a nice thing to see. And if it doesn't go well, then the naysayers can say, you can agree with them and say, okay, it didn't go well, let's not try to change it. And if it does go well, then
yeah. Could we unpack that thing that's going on in Maine? You'd mentioned the two-tiered majority function. How is that going to work?
Yeah, Maine specifically, I think they're using ranked choice voting.
Oh, sorry, I said it backwards. The rest of us are the two-tiered. Maine is going to switch. Thank you.
As far as I know, Maine is using ranked choice voting, and I believe they have already used it in their congressional election. And I also believe they're using the ranked choice voting in the coming presidential election. I could be wrong on that, but so both in the congressional and the presidential elections, I believe they're using this. Not just ranked, and more specifically than ranked choice voting, I believe they're using instant runoff voting for both of them.
Interesting. And then with something like instant runoff, does that mean that voters might have to participate twice, or how do the mechanics of it play out?
So yeah, the term instant runoff, it's meant to indicate, it's almost like you are doing a runoff vote, but instantly. That is, once you've cast your ballot, it's almost like there's an automatic instant runoff vote that occurs. So this is how it works. So everybody casts a vote, as we said before. It's a ranked list of the candidates, so like first most preferred, second most preferred, third most preferred. And this voting method looks at everybody's first choice candidate, and it says, did somebody get more than 50% of the vote among the first preferences? So say more than 50% of people ranked George Washington as first, then George Washington becomes president. Yeah. If that does not happen, then the least preferred candidate is eliminated and the process repeats again. For people who, say if George Washington did not get eliminated, then he would still be the most preferred on certain people's ballots. But say Alexander Hamilton was the least preferred candidate in this first round, he gets eliminated from everyone's most preferred list, so pretend like it wasn't even there, and those people who had Hamilton as their most preferred candidate, now their second most preferred candidate, if you'd like, gets shifted up to their first preference, so all their previous lower preferences get increased by one, and the process repeats again.
That seems nice. I like that in form. It has a lot of neat properties. Seems pretty fair, and it'll definitely have one nice property, that there will be a winner, right? Eventually you'll eliminate all but one person, or maybe sooner you will find a winner, which is a nice thing to have in voting. But I'm curious, there's people say like, oh, we have close elections. And in some ways I think that's probably good. That means, there's a discussion going on. But if elections truly are close, then it seems to me they might be very sensitive to the method by which we vote, which seems odd, right? I would hate to think that the leader is so contingent upon how we pick. Do you have a sense of how sensitive elections are to the mechanism of how they determine their winner? Would the global landscape look totally different if everyone switched election counting processes? I don't know.
I don't know. It's tough to say. There's so many different voting methods out there. There's parliamentary style elections. As I mentioned, there's this instant runoff voting, which is used in Australia. Yeah, that's a tough thing to say. But I can say that as far as sensitivity to, say, corruption goes, that is, how would the outcome of the election change if, say, a few votes were corrupted in some way, they changed by some adversary, then the Electoral College is just not as good as, say, a majority or plurality vote. But yeah, as far as your original question, one immediate example, I guess the obvious answer to your question is, yeah, if we didn't have the Electoral College, then our current president would be different. I guess and same thing goes in 2000. So.
Oh, yeah, great example, actually, yeah. In terms of corruption, earlier when we were discussing it, you had mentioned it's often modeled as a uniform, that any vote could be corrupted. I'm curious if you could unpack that assumption. Like, the corruption I'm thinking of is some evil guy sneaking a bunch of extra ballots into one ballot box, which wouldn't be uniform. Do you find that to be a strong or a weak assumption, or why start there?
Here's the simplest statement I can make. So suppose we're doing election, say I have a million voters or some large number, and the election is going on with two candidates, just to keep things simple. Say I have some voting method, so maybe it's like Electoral College, maybe it's majority vote, something else, but it's some voting method where half of the time, that is half of the combination of the votes, the first candidate wins, and for the other half of combination of votes, the second candidate wins. Okay, so suppose we have this voting method. Another way of saying it is there's an equal chance of each person winning. That's the quick way of saying it. Yeah. So in this situation, suppose, like you said, there's some shady person that changes 100 votes. So they're allowed to change 100 votes, and they can pick whichever ones they want, but they are just changing 100, so some fixed number. In this case, a majority vote will preserve the outcome the best. That is, there will be the smallest number of combination of votes where the outcome changes due to this corruption. So that's sort of the cleanest statement you can make about the best protection against the corruption by an adversary, as you mentioned. Another way you can state this, the corruption mechanism, I think the other thing that you're alluding to from these works. Oh, and by the way, that first statement that I just told you is not, I did not observe that. That was told to me by Daniel Kane at UCSD. So, and a lot of the things I'm going to talk about today were not figured out by me. I'm just sort of surveying some things that other people did mostly. In any case, another way of looking at corruption in voting, which I think I mentioned before, is, as you said, so we're sort of considering all possible combinations of votes that people can make. But then certainly, yeah, maybe there's some person out there who's changing the votes and whatever. But in the aggregate, you can model that as, say, a small probability of changing any particular vote. So is this reasonable as an assumption? Yeah, it's not clear. It's in the aggregate, yeah, but maybe. But as far as an individual vote, no, I don't think each individual vote is really going to have some small probability of changing, right? Yeah, just like any model has assumptions and limitations, this is certainly no exception. Any model is only an approximation to reality, for sure.
There's one topic that comes up a little bit I was hoping you could give me a definition on, and that's the idea of the dictator. Not the guy who won, but the person who participated in the voting. Why are some voters labeled as dictators?
Oh, yeah. This is a nice example to keep in mind when you think about different voting methods. So let's say we have an election with two candidates. Our input is all of the votes of everybody, and the output is the winner of the election. The one election method that people think about and study is the dictator function, or the dictatorship. So this would mean, say, your vote, whoever you vote for, they win the election. That's what we call a dictatorship. It's a nice one to think about because, well, intuitively it agrees with what we think of as what a dictator would do, right? Everything that they say is what happens. But it also has some nice external properties that pop up.
So it's simultaneously, or in a way, it's surprising that there could be a dictator. I guess, maybe if you're electing the treehouse or the block club leader, it makes sense on paper. Yeah, this one person is the deciding vote, but I struggle to map that to a national election. Do I just lack vision, or how do you see these things fitting together?
Yeah, the way I presented it is probably not so intuitive. It's another way of saying it is everybody else's vote, we're ignoring them, so it's almost like they didn't happen, right? So the dictator election is basically one person asserting whatever they do is what happens, and they are the leader, right? So in practice, I guess that is sort of what a dictator does, right? They decide that they're the leader, yeah?
Their vote is the only one that counts at the end of the day, yeah. Maybe there's someone in a battleground county that is exactly that.
Yeah, I guess.
Well, I'd love to get into a little bit about the mathematics that you need to use to study these sorts of things. No surprise that you need some combinatorics, but I was surprised with what I saw as a pretty diverse sampling of different aspects of math. There's, maybe a little topology here and measure theory and things like that. What are some of the tools you apply to study this area?
This area, I guess you could call this general area social choice theory or something like that. I don't know. But yeah, there are a lot of tools, and that's what kind of makes it fun. And so one of them you'd say is probability. So starting out at the basic level, that would be the things you would learn, say, in an undergraduate probability class. So things like the central limit theorem, things like that. So that'd be a big one. Another big tool that I like to use, which actually originally got me into this topic, would be Fourier analysis. So I guess more commonly, a lot of mathematically inclined people know Fourier analysis, say, from signal processing perspective. That's how we encode audio signals signals and compress them, things like that. But in this setting of, say, voting, there's also, you can do Fourier analysis there too. It's not exactly the same as, say, dealing with sound waves and things like that, but a lot of the intuition can be the same. So that's a big tool that we use. You could say this falls under the umbrella of statistics. There's many interesting statistical questions here and tools. You could also put this under the umbrella of game theory. There's always sort of new tools that people bring around. But yeah, I'd say the two main tools that are used are probability and Fourier analysis. Me personally, I've even been using some differential geometry recently, so a little more specialized, maybe also known to people in, say, physics. Differential geometry, I guess people would mostly know from hearing about Einstein's general theory of relativity. I'm not doing anything that fancy, but the tools, at least, that's been around at least 100 years. I've been using them myself.
So what are your dimensions? Einstein's are space and time. What are you searching over?
Yeah. So if we have an election with two candidates, so one way of thinking about, so make a list of all the votes, right? So say we have 1 million voters and we have two candidates we're voting for. So we make a list of all the votes. So just put that in one long list, say 1 million long list, and say it's a list of minus ones and ones. So -1 denotes voting for whoever, George Washington, and +1 denotes voting for Alexander Hamilton. So we can think of that as a 1 million dimensional vector, okay? It's a list of 1 million numbers, and so a mathematical term for that would be, say, a 1 million dimensional vector. That's the setting that we're in. So if you ask about dimension, I would say whatever the number of votes you have, that's the number of dimensions that I'm dealing with. So actually this whole enterprise, and not just this social choice stuff, but also a lot of modern statistics, deals with statements you can make in an arbitrarily high dimensional space. And a lot of the statements that you prove also have to deal with arbitrarily high dimensions, which can make it hard, but it can also make it interesting when you can do that.
Definitely. I'd like to touch more on the corruption angle of things. We described it earlier as the opportunity for a bad agent to go and flip, a few votes that they get to pick, I guess. But there's more to it than that. Could you talk a little bit about the adversarial work that you were describing in the paper?
Yeah, so I think I already touched upon the adversarial aspects of, say, voting in an election with two candidates. One sidebar is all these questions for 3 or more candidates, they're actually quite a lot harder. And so that's something that I've worked on and some other people have worked on. Maybe let's think about, say, the Electoral College. So brief review of how the Electoral College works. Once again, simplify to just having two candidates and ignore places like Maine and places like that do a little different. But each state runs its own majority vote, and whoever wins the election in that state, they get all the electoral votes in that state. And then all the states feed into one big majority vote. Now, technically, there could be a tie. For the purposes of what I'm about to say, let's just ignore that case. But yeah, it could actually be the case that if you have two candidates that both get the same number of electoral votes and then, it goes to the House and whatever. That's beside the point that I'm about to make, but it's definitely something that could happen. In any case, so this is how the Electoral College works. It's like having a separate majority vote in each state, and then all of those results get fed into a big weighted majority vote, right? Different votes have different weights. Like California has a lot more electoral votes than Wyoming, for example. So you can do a calculation, and if you're in the situation that, say, all the votes are corrupted with some small probability, like say it's a small number, then probability of the outcome changing is something like square root of that small number. If you just had a straight up majority vote. In something like Electoral College, that's like having a little majority vote in each state, and then they all get fed into some big, just think about the states having the same sizes. It's like having another majority vote on each of those individual majority votes. So since it's like iterating two majority votes on top of each other, if each vote is changed with some small probability, so some small number, then the probability of having a changed outcome is something like square root of the small number, because it's sort of like iterating it twice. So that would be small number to the 1/4 power. You could consider like a 3-tier electoral college where, say, maybe each little city does their own little majority vote, and that gets fed into the majority vote of the state, and that gets fed into the majority vote of the nation. In that case, we ask the same question. If you have a small probability of corrupting the vote, what's the probability that final outcome is changed when I compare the result before corruption compared to after corruption? And now that if we have 3 tiers, that would be like small number, square root of that, square root of that, square root of that. The probability is like small number to the 1/8 power. And you can keep going. So, the more tiers that you have, if I have, say, 100 tiers, then the probability of changing is something like small number to the 1/2 to the 100, which is quite close to 1. Small number but if I have it to a small power, it gets close to 1. From this somewhat heuristic argument, you see that something like Electoral College with several layers will be very prone to corruption. And that's exactly what a deep learning network is. Well, not exactly, right? But that's something like what it is. It's like several layers of majority votes, at least in some cases, that's what it is.
For sure. Max pooling and stuff like that, that's a majority vote.
Yeah, and so the more layers that you have, so the more sensitive it is to say corruption. And so there's this heuristic that, once again, probably in many cases people have workarounds for this situation, or maybe they say in practice we don't observe this, but still you could make a heuristic argument that many deep learning networks are susceptible to changes in the inputs. And so for this reason, there's a group of people that I find very interesting what they're doing. They just design algorithms that are supposed to protect from these changes. So they call them robust algorithms. So they try to design algorithms that are robust to arbitrary changes in the inputs, unlike what we expect from deep learning networks. And I find that very interesting. I haven't worked on that myself, but I find it very interesting.
We always think of elections as being, part of the democratic process, or that's where voting kind of is most top of mind, but that's not the only place voting takes place. Do you have any examples of other areas you think are interesting, be it, how shareholder voting takes place or any of these other mechanisms?
Yes, I guess one example is one I wrote up in the survey article, which is how the UN Security Council works.
This is very interesting, yeah.
Yeah, it's a classic example. So it's not due to me, but it's been dealt with in several decades. Yeah, 1965, I think, was what this example is from. So you have these permanent members, so their votes are to count for more. You have the non-permanent members, so they're like the votes that just count for less. So they change the rules, and then there's this interesting discussion of how, after the rule change, did it make it better for the non-permanent members or worse? Yeah, they did this little calculation to show that, it's pretty much the same, but it did change a little bit, but it's basic.
Well, Stephen, this was great. I definitely want to encourage people to check out Designing Stable Elections. It's a deeply mathematical treatise, which is great. It really takes you through these things step by step, but it's also a good overview of the types of topics that are out there. So I really appreciate having it as a guide. Where can people follow you online?
Well, I guess I just have my website. It's just, I don't have any social media or anything, so I can't necessarily plug that or anything, but I have my website, which is just myname.org. I also, if you want the more general audience version of the article, it was not with the same title, but it was in the conversation. So you could check that out if you want the less technical version of this survey article.
We'll have a link to that in the show notes so people can check it out. Awesome. Well, Stephen, thank you so much for your time.
Thanks a lot.
That concludes this installment of Data Skeptic Consensus. Our guest today was Stephen Heilman. Our theme song is Paradox by Odling. Claudia Armbruster is our associate producer. Vanessa Burciaga does guest coordination. And I've been your host, Kyle Polich.